we start with 7.6, which is about Pythagorean theorem applications. Pythagorean theorem is about right angle triangles, a triangle with a 90-degree angle at this corner here, the sides A, B, and the diagonal side C. And the theorem states that a squared plus b squared equals c squared. If you transpose the b and take a square root, you get a equals root of c squared minus b squared. If you transpose a squared and take a square root, then b equals root of c squared minus a squared. If you just took a square root, then c equals root of a squared plus b squared. Now, if there's a question about distances and Cartesian coordinates, given a point at x1, y1 and another point at x2, y2, what is the distance between them? Well, draw this horizontal line and this vertical line. This has a length equal to the difference in the x values, x2 minus x1. This side here is a difference in the y values, y2 minus y1. And so using this version of the Pythagorean theorem, you get that d, the diagonal, equals the square root, a sum of the squares of these two sides. So root of x2 minus x1 squared plus y2 minus y1 squared. 761, 762. So, for example, right angle triangle, AB, diagonal C. A is 6 and B is 8. What's C? Well, C is root 6 squared plus 8 squared. That's root of 36 plus 84. That adds to root 100, which is 10. So the third side is 10 feet. Here we have sides A and B are 8 and 15. What's C? C is root 8 squared plus 15 squared. Root of 64 plus 225. These add up to 289. Root 289 turns out to be 17. So it's 17 along the diagonal. So this one's a 6, 8, 10 triangle. This is an 8, 15, 17 triangle. Now here, B is 40 feet. Sorry, is 9 feet. C is 41 feet. What's A? Now A is one of the sides rather than the diagonal. So the equation is root of c squared minus a squared minus. So 41 and 9, root of 41 squared minus 9 squared. 41 squared is 1681, 9 squared is 81. Subtract to get 1600. Root 1600 is 40. So this side A is 40 feet. All right. All right, here we have a right angle triangle with two equal sides. 3.2 feet by 3.2 feet. All right, so the diagonal is root of 3.2 squared plus 3.2 squared. That's, this is 3.2 times 2. Root 3.2 squared times root 2. 3.2 root 2 feet, which is approximately 4.525 feet. Here's the distance between the point 6 by 8 and 12 by 16. The difference is a square root of the sum of the squares of the differences of the coordinates. That's 4 ofs in a row. Square root of, sum of, squares of, differences of coordinates. Okay. 6 minus 12 goes here. 8 minus 16 goes here. So we have a negative 6 squared plus a negative 8 squared. That's 36 plus 64 square root. Root 100 is 10. The distance between these points is 10. Now I'll try the distance between negative 2 by 1 and 3 by 4. All right, square root of sum of squares of differences. Negative 2 minus 3 goes here. 1 minus 4 goes there. So it's negative 5 squared plus negative 3 squared. That's root of 25 plus 9 is root 34. So the distance is the square root of 34. Or how about distance between negative 2 by negative 1 and negative 5 by 18. Okay, square root of sum of squares of differences. 2 minus negative 5 goes here. Negative 1 minus 8 goes here. 2 minus negative 5 is a 3. Negative 1 minus 8 is a 9. 3 squared is 9. 9 squared is 81. Add them up. Square root of 90. Okay, we can pull out a square factor of 9. Root 9, root 10. That's 3 root 10. So the distance between these 2 points is 3 times the square root of 10. All right, here we have this box, 24 by 24 by 4. And can a 34-inch femur fit in this box? The idea would be have to go from point A to its opposite catty corner point B. Now, there's a 3D version of the Pythagorean theorem. We have length A here, right angle here, right angle here. And then the 3D distance is the square root of the sum of the squares of all three sides. In this case, it's 4, 24, and 24. So square root of 4 squared plus 24 squared plus 24 squared. This comes out to root 1168, which is 34.176, which is just a bit bigger than 34 inches. So yes, I suppose it can, but I'm a little worried if a femur has bulbs at both ends, it might not fit in that corner after all. And I suppose I should also, if this is a fossil femur or something, I should pack it up with shredded paper or cotton or something, whatever. Okay, so there's that. Okay, I believe we're completed here.